Alright, in this section here we're going to be solving logarithmic and exponential equations. Alright, I want to go ahead and just start with some exponential equations. Now, in a previous section we worked solving exponential equations, but it was something like this. Let's say I had 2 raised to the x power. Okay, well, we can look at this and say, well, what can we plug in for x right here to get this whole side to be 16? Well, if I were to say, let's let x be 4. So that means it'd be 2 to the 4th, which is 2 times 2 times 2 times 2. So that's 4 times 4, and that would be 16. So the answer would be this right here, x is equal to 4. Now, there was another way of doing this. We could have written 2 raised to the 4th power, and then we had 2 to the x, and since now our bases were the same, we would take the exponents and set them equal to each other, and so therefore it became apparent that x was equal to 4. Alright, but now we're going to have a situation where we're not going to be able to do that. For example, let's start with this one here. Let's say 5 was equal to 11 raised to the x power. So what in the world are we going to have to plug in for x here in order to get this to be equal to 5? Well, what we're going to do here is we're going to use the log properties. I'm going to take the logarithm of both sides. So this is going to be the log of 5 is equal to the log of 11 raised to the x. Now I'm just going to throw this in over here real quick. This is an exponential form, and what if we wanted to get it in log form? So you remember how to go from exponential form into log form. Okay, that's something that you got to remember on how to do that. Okay, so to get this in logarithmic form, this would have been log base 11. That's the reason I keep calling this the base right here. This is known as the base. Log base 11 of 5, okay, that's supposed to be a parentheses there, is equal to x. And that's what we're trying to find. What is x right here? Well, there was a property that we can actually rewrite this piece here as log 5 over log 11, and that would be equal to x. Okay, now I said, well, look, let's go back over here. We can take the log of both sides, and then we can use that property, that power property up here. Remember taking the x and bringing it out front? And then we're solving for x, so you just divide both sides by log 11. So this is log 5 over log 11 is equal to x. So that's where this comes from, just taking the log of both sides right here. You see that? Okay. So what we'll need to do here is basically plug that sucker into a calculator. Log 5, unless we're given what log 5 is or an approximation, and we're given what log 11 is. We just plug that in and we get that number, and that would be our x value. Okay, so I don't know, I guess we'll do that real quick. Alright, I went ahead and plugged that into the calculator, and I got x is approximately 0.671. Now these little squiggly lines right here, alright, they kind of look like that, and little squiggly lines represent approximation. Okay, so I just rounded to 3 decimal places. Anyway, if you take this, go out to 6 decimal places or whatever, plug it in up here, 11 raised to that number right there was going to be equal to 5. Now, that's only if you use the exact value here. Okay, this would just be approximation.